Hey, welcome everyone. Here's a video for week 11 Desmos activity for Algebra A, and just to help you guys get started in what to do. So week 11 is all about linear modeling and using linear equations to make sense of data and patterns and things that we see around us. The whole context of this Desmos activity is the Olympics and the 400-meter race. So 400 meters is one lap around a standard track. What do you think the world record is for fastest 400-meter time for women? Again, put any answer you in. Just kind of thinking about it. I'm going to type in 1 minute. That's pretty fast. Submit that, and I'm going to go along. So what does the trend look like? Sketch a graph of what you think is happening to the fastest woman's 400 time from 70 to 2015. Describe your thinking. So I'm going to grab the pencil icon. And what do I think is happening? Here's the women's time in seconds. Well, maybe, we're getting faster. So it's kind of something like this. Maybe it gets a little slower. Maybe someone gets faster. I think in general, people are getting faster and faster. That would be how I would describe my thinking. Okay, here is 15 years worth of data. So we're going from 1970 to 1985, and we're looking at the women's times for the 400 meter. Looks like Germany dominated, right? A lot of Helga Seidler, a lot of Marita Koch. Notice the time is given in seconds, and it's actually 51 seconds. So my estimate of 60 seconds was a little bit too late. But we're going to turn this table into a graph and see if we can use the graph to make a better prediction. So now here's the part that's going to take a while, is you need to go back and forth putting the data into this table. So they've already give 2, that's for 1972, in a time of 51:08. But let's start with 1970 and 51.02. So I need to go 1970 is 0 years after 1970 to 51.02. So this X column is years after 1970, the Y column is the time. So here I would do 1 year, and it was 52.14. And you just go back and forth. Let me do a few more for you. 73 was 51.27. And 74 was, 74 was 50.14. Okay, I now have all the data in there, and you can see it looks like it's kind of aligned, right? In fact, if we zoom in a little bit, zoom in a little bit more, you might even say it is slowly decreasing, right? These values are a little bit less than these values. Now, what you're going to do is once you have your data in, you're going to come up with the line of best fit. So pick a couple points, find the slope, find an equation using point slope form, and then type in your equation. And then you're going to make sense of what does your slope mean in terms of the context of the problem. What does the y-intercept on your equation mean in real world units? So if you have point slope form, you'll have to rearrange it to get it into y-intercept form. And then you're going to make a prediction using your equation for the year 2015. So you use your equation, put 2015 in for x, and calculate what the y value you get, and then you'll see how it fits. So follow the rest of this along and use the data and have fun doing some linear modeling.